So today we're going to look at water movement. We're going to start by using some eggs. These eggs have been sitting in vinegar overnight. By sitting in vinegar, they've lost the egg cell, so they no longer have that white protective cell. I'm rinsing the first one off now, and now you can see kind of we have this egg without a cell. It's kind of a rubbery feeling to it because it doesn't have that hard rubber cell. We're going to take this first egg, we're going to take it over the scale and weigh it, and then we're going to place it in a beaker of water and let it sit for at least 24 hours, and then come back and take the mass afterwards and see what it looks like afterwards. Then we'll do the same thing with a second egg. So second eggs, again, I'm going to rinse off. It's going to look very similar to the first egg. It's been sitting in vinegar for 24 hours, a little over 24 hours, and again, it's lost its cell. So we'll weigh both of these. The second one we're going to put in cornstarch. So our first egg, egg number 1, weighs approximately 86.43 grams. So 86.43 grams for egg number 1. Zero out our scale. And egg number 2, the one that's going to go in cornstarch, weighs about 84.97 grams. So next we'll place them in our beakers for them to go in the correct solution. So our first egg, egg number 1, is just going to go in a beaker of regular tap water. So we'll just put some tap water in, and then add in egg number 1. Make sure the egg is completely covered in water, and then let it sit again for at least 24 hours, and then come back and check on it in 24 hours. Then for egg number 2, we're going to use corn syrup and repeat that same process. So I'm going to put the egg in a beaker, add in my corn syrup, and again we'll check in 24 hours. We'll show you our set product and check in with you in 24 hours. So here we are. It's been over the weekend, so it's actually been about 72 hours. You would expect similar results after 24 hours. But if we look at our eggs, we have our egg that was placed in the water and our egg that was placed in the corn syrup. We're going to take each one over to the scale and weigh it and get our final mass. So starting with our water egg, again we pull it out, you can see it's gotten larger than when we started with. And now we're at a mass of 95.54 grams. So that's for our water egg. And again, you can see it's gotten much larger, much thicker in size. So we had that change in size. Then we have our corn syrup egg. You can see it looks very deflated. I'm going to try to get it out without breaking it. But you can see it's like a deflated soccer ball. Zero out our scale, and then place that one on there. And now we have a mass of 45.15 grams. And again, you can see that very deflated looking egg. So hopefully you've gotten your data for your egg. Again, our water egg, much inflated. Corn syrup egg, very much deflated. For the next part of this experiment 1, we're going to start by taking a 250 milliliter beaker. In this case, we're just going to use tap water. You could also use distilled water. And we're going to put approximately 200 milliliters in. It doesn't have to be exactly, but we're going to put approximately 200 milliliters. And then the first thing we're going to do with that is do a glucose test. So we have these glucose test strips, and we're going to take these glucose test strips and just drop it into beaker and see what the reading is. So to do this, you just take your test strip. It's got a yellow tip on the end. You put it in your water for just a couple seconds. You pull it out, and as it starts to dry, you compare it to the colors on our label. So we see which one it matches up with, and in this case, we get a value of 0. So we have a 0 parts of glucose in our beaker. Next, inside that beaker, we're going to place a few drops of iodine. So that gives us a few drops of iodine. And as we add the iodine, we'll swirl it around. We want about 10 total drops. I'll just put a squirt or 2 in, and it gives us this dark and yellow color. So that's our first observation. We have a 0 glucose, and we have this golden yellow color in our beaker. Next, we need to create a cellulose tube. We'll do that, and then catch you once we have the tube ready. So now that we've tied one end of this dialysis tube and start creating our dialysis balloon, we got a funnel in the top to pour our two liquids. We have a starch solution and then a cellulose sucrose solution. We're going to start by pouring in 5 milliliters of the starch solution. Then we'll pour in 5 milliliters of that sucrose solution. So that gives us a total of 10 milliliters in the bag. If we're doing an observation for the appearance of the bag, you can see it's kind of a cloudy white appearance inside the bag. Then we tie up the top, and then we'll drop the bag into our beaker. So I'll tie up real quick and rinse it off, and then we'll drop it in, and we'll catch you then. So we've gotten our dialysis balloon created. We've tied off both ends. Inside the balloon we have our starch and sucrose solution mixed up together, and we're dropping it into our beaker with iodine and water. We'll allow it to sit in there for approximately 20 minutes, and then we'll come back in 20 minutes and see what it looks like. While we let our first solution, our first dialysis balloon sit in the solution, we'll set up our experiment part B. In this part, we're going to use 100 milliliters of that same starch solution. So I'm going to pour that up to, again, it doesn't have to be exact, but I'm going to pour up until about that 100 milliliter mark. And we got 100 milliliters of our starch solution. And this time, again, we're using a dialysis balloon. So I've already started this one, and we've already tied off the bottom. We just got to open up the top, put a funnel in, and inside this balloon, we're going to put in 10 milliliters of water. You can use distilled water, we can use tap water. They're both going to give us the same result in this case. So I've already measured out my 10 milliliters, and I'm just going to pour that into my... So we have our 10 milliliters of water in the bag. I'm going to keep the bag open as I'm going to add a few drops of iodine inside the bag as well. So to my water, I'm just adding a few drops of iodine. I want to make sure we get it down into that water. So now we should be able to record the appearance of inside the bag and inside our beaker. So our beaker has a nice cloudy white coloration appearance to it, and our bag has this golden color. I'll tie it off, rinse it off, and then we'll put it in our beaker again for 20 minutes. So tie it off, rinse it off in case we got anything outside the bag. Make sure we remove anything that got spilled outside the bag. And then we'll drop it in our beaker, and we'll leave it to sit in that solution for about 20 minutes. Now we're going to proceed with experiment part 2. In experiment part 2, we are using a dialysis balloon. This time we start with a beaker, and we're going to place in approximately 60 milliliters of this unknown concentration of sucrose solution. Again, approximately, we're not worried about getting exactly 60 milliliters this time. So I'm just going to about 60 milliliters of our sucrose solution. So this is unknown concentration. We're not sure what this concentration is. And overall in this experiment, throughout the class, you're going to have 6 different known concentrations tested inside your balloon. So you could have 0.0 sucrose, 0.2, 0.4, 0.6, 0.8, or 1.0. In this particular case, I'm going to use the 1.0 inside our balloon. So I have my dialysis balloon set up. We're going to pour in 5 milliliters of that 1.0 sucrose solution, and then we're just going to tie up our balloon. After we tie it up, we do need to weigh it, so I'll tie it up, and then we'll catch you at the scale to weigh it. So now at the scale, we're just going to weigh our balloon with the 1.0 solution, and we get a mass of 7.105 grams, 7.15 grams. Now that I have my mass, I'm just going to put my dialysis balloon into our solution, and this time we want to let it sit for 30 minutes. So we'll put it inside that solution and let it sit for 30 minutes. After 30 minutes, we'll take it out, dry it off, and again take our mass. So that one's going to sit for 30 minutes. You can kind of see an update of kind of what's going on with our other balloons while we wait. And these balloons still have 10 to 15 minutes left, depending on which one we're looking at. So now it's been about 20 minutes since we placed our dialysis balloon in. We can see our beaker solution still a golden yellow color. And then if we pull our balloon out, you can see it's a purplish color. That purplish color is going to indicate that the iodine has moved into the bag. When it comes in contact with starch, it causes this purple color we see here. So that's experiment 1A, and then if we look at 1B solution, if we look around the balloon, you can see it's starting to change to that purple color, same as what we saw inside the balloon of the other one. If we pull our balloon out though, you can see it still has that golden liquid on the inside. If we rinse it off, we could get that purple appearance. That's just from the bag being inside that liquid. But inside, you can see it's still a golden color. So again, that indicates iodine was able to move outside the bag and into our beaker. However, the starch that's inside the beaker was not able to move inside the bag. We'll catch you on part 3 in about 10 more minutes. So it's been 30 minutes. Now we're going to take our balloon out of our unknown concentration of sucrose solution and weigh it, and then we'll see what that final mass. So we had an initial value of 7.15, and now we're ending at 8.21. So our final value is 8.21 for our dialysis balloon in the 1.0 concentration inside the balloon. So hopefully we're able to see some movement of different molecules or water throughout this lab process. Hopefully you got the data you need, and if you can't find it, there's a link below for all the information for experiment 2 for values for each one. Thank you and have a great day.